Hello students, today I am going to discuss one of the topic known as disk scheduling. One of the major tasks or main task of operating system is to handle input-output devices as well as disk devices, storage devices in efficient manner. For the operating system, as we know, it handles all the requests of the processes, active processes for storage devices in which the two main issues are involved. The first is access time and the second one is the bandwidth, that is number of bytes transferred within a given time interval. Now these are the issues related to disk scheduling. Okay. For storage devices like disk drives, the main task of operating system is to handle access time as well as the bandwidth of the system efficiently. The access time of the system has two main parts or major components. The first one is the seek time. The seek time is the time for the disk arm to move the heads to the cylinder containing the desired sector. That is, it is the time taken by the disk arm to move head of each platter to the cylinder containing the desired sector. Whereas the second component is the rotational latency, that is the extra time for the disk drive to rotate the desired sector to the under the disk head. Means when head moves to the track, then rotational latency is the time taken to rotate the platter for moving the desired sector under the disk head. So these are the two components by which we can compute access time. And the second issue related to disk management or disk scheduling is the bandwidth. The disk bandwidth is the total number of bytes transferred divided by the given time interval. That is, for the given time interval, number of bytes transferred, we can divide that number of bytes transferred by the given time. That given time means the time between first request and completion of last transfer. Now, when a process needs input-output or data from disk, a system call is issued to the operating system. Operating system then tackle these requests accordingly. If disk drive and controller are busy, then these requests are placed into queue. Otherwise, if disk drive and controllers are free, then these requests are processed immediately. Otherwise, all the requests are placed into queue. And in multi-programming system where multiple processes are active, number of requests from different processes are issued by processes, and at the same time these requests are placed into a queue. Now I am going to discuss one of the disk scheduling algorithm known as first come first serve. As name suggests, first come first serve, that is FCFS disk scheduling algorithm. The requests are processed according to their arrival, that is in first come first served manner. Now I am taking one example by which we can understand the sense of this scheduling algorithm. For this, suppose there are number of requests are placed in queue for IO blocks on cylinder. That is, these are the disk requests from the processes. The request is for 99 number of cylinder, 184 number of cylinder, 38, 123, 15, 125, 66 and 68. These are the requests for cylinders generated by processes. So, for this we suppose a disk with 200 number of cylinders, because there are the maximum request is for 184, so we can use the disk size in terms of cylinder from 0 to 199, means 200 number of cylinders. So as we know, the platter or cylinder are represented as a circular form, but to represent the disk movement we draw a straight line and we represent this number. This represents the disk cylinder on the disk accordingly. Now, as we discussed earlier, in first come first served disk scheduling, the requests are processed according to their arrival. So we start from 99, and in this example we also suppose that currently the head is on 54 cylinder number 54, that is previously had processed the request at 54. So at that moment the head is on 54, and after that we consider this example or these requests accordingly. So currently we suppose the head is on 54. So we have to start from 54 and process the request of 99. So downward we can move. This represents the time interval taken from cylinder 54 to 99. So we down the arrow. Now from 99 the next request is 184. So the head is moved from 194 to 99 to 184. Now next moment is 38. So again the disk head move from, this is somehow down arrow, 38, then 123. So again this head move from 38 to 123, then this move to 123 after 15. So this move to 15, then 125. So head move to 125, then 66, then head move to 66, and now finally 68. So these are the disc head movement. Now for these movements we can compute the displacement of head from one cylinder, one request to another request. So the head movement or displacement from starting 54 to 99, we can subtract 99 to 54. Then next movement is from 99 to 184. So we have to subtract 184 minus 99 to compute the disc displacement or disc movement, head movement. Now from 184 to 38. So 184 minus 38, then 38 to 123, that is 123 minus 38 plus 123 to 15. So the movement is from 123 to 15. The displacement is, we compute displacement from 123 to 15 by computing 123 minus 15. Then 15 to 125. So next displacement is 125 minus 15. Then 125 to 66. So 125 minus 66, then 66 to 68. So 68 minus 66. These are the head movements for processing the given set of requests. So when we compute this one, then this is the 45 plus 85 plus 146 plus 85, 108, 110, next is 59 plus 2. So these are the displacement. So total head movement is 640 cylinders. So this is the first algorithm in which to process the request according to their arrival takes 640 cylinder movement of the head. Now next scheduling algorithm, this scheduling algorithm is shortest seek time first SSTF scheduling. As name suggests, this algorithm selects the request with minimum seek time from current head position. That is, as seek time increases with the number of cylinders traversed by head, so SSTF algorithm selects closest request from the current head position. So this required computation of the minimum head movement from current head position to each request. I am discussing this issue of this point using an example. Suppose the request from different processes are placed in queue are as follows for IO blocks on cylinder: 99, 184, 38, 123, 15, 125, 66 and 68. These are the requests from different processes, and suppose currently head is on cylinder number 54. So for each request we have to compute the head movement from the current location. The current location is 54. So from this is the nearest request, that request in which lowest head moment is required is of 66. So head from current location 54 moves to 66. The down arrow is used to represent the time taken in between. So we move the arrow downwards because of this consideration of time. Now from 66 head moved to 66. The first request is processed is 66. After that, the next request which required minimum displacement of head is 68. So head moved from 66 to 68. After that, next head movement is either to 99 or to 38. So 68 to 99 is 31 and 68 to 38 is movement is 30. So head now move backward to process request at 38. After 38, the next minimum request is of 15. Now there is no backward request from pending request, so head moves onwards and process to request at 99. After 99, it moves to 123, after 125 and then finally 184. This is the movement of head for each request in the queue. Now we have to compute the head movement. For this, the head moment can be computed as 66 minus number 66 head movement equals to 66 minus 54 from this to this. So movement is computed as 66 minus 54. Then from 66 to 68. So because the positive movement of head is always positive, so higher number can be placed first, then the lower number. From 68 to 38, so 68 again, 68 minus 38 plus 38 minus 15 plus 99 minus 15 plus 99, 123 minus 99 plus 125 minus 123 plus 184 minus 125. These are the head movements for each request. So the difference equals to 12 plus 2 plus 30 plus 23 plus 84 plus 24 plus 2 plus 59. So the total head moment is 236 cylinders. This is the SSTF algorithm.